In this video, we are going to look at current in parallel circuits as problems. Okay, let's turn that sound off. So, current in parallel circuits. Now, what we're going to do, let's start with a very simple circuit. What I'm going to do is say, got one cell, got a bulb that's going to be in one branch, we've got a bulb that's going to be in another branch, and I'm not going to draw ammeters in yet because I'm going to show you, I'm going to represent the current slightly differently in this. Now, when you draw circuits, as a reminder, you should be using a ruler, but just for the video, that takes a bit too long. So I'm keeping it simple, I'm just doing it by hand, but I'm keeping it neat. Now, in this circuit, I'm going to tell you a fact. Current goes from plus to minus, and I'll tell you that the current at this point is 0.2 amps. Okay, that arrow points from plus to minus, 0.2 amps. Now, we know that there's a circuit rule that current is the same current that that comes out of the battery is the same as the current that goes back into the battery, and that's the same as a cell. So if I asked you what the current was here, hopefully you've got it. It's 0.2 amps. Some people at this point think that it's zero. They say, well, doesn't it get used up? No, it doesn't get used up. So current that comes out of the battery goes back in. There's no using up that happens. But what does happen is it splits down these branches. These two bulbs are equal, and what that means is 0.1 amps goes down there, and 0.1 amps goes down there. What that means is that 0.1 amps comes out of that side, and 0.1 amps comes back at this side, joins back up to make 0.2 again. Okay. Now, at this point, a lot of people ask and say, well, surely that doesn't make sense. Surely something gets used up in the circuit. And something does, and there's another property called potential difference, often referred to as voltage, but we're not going to cover that in this video. That does look at the energy that gets used up. So if we look at a more complex circuit now, if we then say, right, I'm going to take my my cell, and I'm going to put two bulbs in each branch. And I'm going to put an ammeter here. I'm going to put an ammeter here. I'm going to put an ammeter here. And I'm going to put an ammeter here. And the way I'm going to connect that up. Oh, now I've done something naughty. I'm going to fix it. You shouldn't come in at the top of components, you should come in at the side. It just means that's going to look a little bit funny. So really, I should redraw that, but it's not a complete disaster. Now, so this line should come out a bit wider and come down. Now, these are the same components. So you've got two extra bulbs. They're identical to these bulbs. So the cell's the same. The ammeters are the same. Sorry, the ammeters are the same as where I've drawn the arrows, and the bulbs are the same. If you have the one cell and one bulb, you've got 0.1 amps. The one cell with two bulbs, it is now twice as difficult for the current to get through. So hopefully what you're thinking at this point is that current is going to reduce to 0.05 amps. And that's going to be the same along the whole branch. And the same with this branch here, it's going to be 0.05 amps. What that means is that the current coming out of the battery to supply 0.05 and 0.05 must be 0.1. And equally, the current comes back down here and comes back down here must add up to 0.1 amps so that the current's the same going in and out of the cell, and you've got the current split between the two branches. And it splits equally in these branches and equally in these branches because you've got the same number of bulbs in each branch. But in this circuit, I'm going to put one bulb in this branch. I'm going to put two bulbs in the second branch. Okay, now in this circuit, the way you're going to work out the total current coming out and into the battery isn't by sort of copying things directly over from this circuit. Some of the numbers will be similar, or about the same, but we need to do them right. To work out the total current coming out of the battery, you have to add up the current in the two branches. Here we go. First branch is one cell, one bulb. And over here, one cell, one bulb. Remember, I'm saying these are all identical components. One cell, one bulb, 0.1 amps. Means here, we've got 0.1 amps. One cell, two bulbs. One cell, two bulbs, 0.05 amps. So what that means is, this, to feed 0.1 amps and 0.05 amps, you need 0.15 amps. And of course, what will be coming back in is 0.15 amps. Sorted. So, let's look at two new scenarios. One, I'm going to double the number of bulb cells here. I'm going to use the same bulb here, the same two bulbs here. Sorry, going a little bit too quick. Not neat. Apologise for that. Doubling the number of cells without affecting the bulbs in this circuit, this point, I'll get 0.2 amps. In this point, I'll get 0.1 amps. This point, 0.3 amps. This point, 0.3 amps. So, everything has doubled because you double the number of cells, double the pushing power. Now, this is where I'm going to draw a bit of a silly circuit. I'm going to use two cells here. And I'm going to start with one bulb. Now, the current going out and into the cells is always the same. With two cells and one bulb, we'll get 0.2 amps. Now, if I add an extra bulb, you then get 0.2 amps through here and 0.2 amps through here. Which means this is now 0.4. If I add another one, see, these two don't change. This one takes another 0.2 amps, which means this is now 0.6 amps. There's another 0.2, which means 0.8 amps. And if we do another one, we're up to 1 amp coming out of here. And what that means is, if I look at this circuit, at this point, I've got 1 amp coming out of here, 0.2 amps, and I've got 0.8 amps there. At this point, because another 0.2 amps comes off, I've got 0.6 amps. At this point, I've got 0.4 amps. And at this point, 0.2 amps. Then they join back up. So at this point, 0.4 amps, 0.6 amps, 0.8 amps, and we've got 1 amp going back in. Okay, so if you think about it, it does all make sense. In series circuits, which I've got some here that we've looked at in another video, if you increase the number of bulbs, the current goes down, which means the bulbs get dimmer. Okay, there's another property that reduces across them as well, but they get dimmer. in a parallel circuit, the total current coming out of the battery increases as you add parallel branches, which means you can keep bulbs at similar, the same brightness if you keep the same number in each branch. So all of these will have the same brightness. But what that means is that you're drawing more current from the battery, which means this will be brighter, but the battery won't, the cells won't last as long. Whereas over on this side, as you increase the number of bulbs, you reduce the current, which means you reduce the sort of output power to the circuit, which means that the batteries will last longer. Okay, and that is about that. Sorted.